Hello everyone, welcome to this ArcGIS tutorial. In this video, we will learn about some basic terminologies of map projection and coordinate systems. We will also explore how to work with geographic coordinate systems and projected coordinate system in ArcMap. First, let's explore the table of contents. You can pause the video here to check the details. So, what is coordinate system? Coordinate system is an arrangement of reference lines or curves used to identify the location of points in space. The most common example is Cartesian system for two dimension. For Earth, special reference is equal to the datum, projection and coordinate system combination. Now, let's learn what is datum. In surveying and geodesy, a datum is a set of reference points on Earth's surface against which position measurements are made, and often associated model of the shape of the Earth to define a geographic coordinate system. What is geographic coordinate system? A geographic coordinate system or GCS is a reference framework that defines the locations of features on a model of the Earth. It's shaped like a globe, spherical. Its units are angular, usually in degrees. Using latitude and longitude, data is located on Earth's surface. What is latitude and longitude? Longitude is an angle from the prime meridian measured to the east. Longitudes to the west are negative. Latitudes measure an angle up from the equator. Latitudes to the south are negative. Let's see what is projected coordinate system. A projected coordinate system or PCS is flat. It contains a geographic coordinate system, but it converts that into a flat surface using math algorithms and other parameters. Its units are linear, most commonly in meters. A projected coordinate system tells the data how to draw on a flat surface, like preparing a map. It mathematically transforms the 3D Earth so that it can be modeled in 2D, resulting in distortion. What is distortion? Distortion is the misrepresentation of the area or shape of a feature. There are no map projections that can maintain a perfect scale throughout the entire projection because they are taking a spheroid and forcing it onto a flat surface. Four types of distortion due to projected coordinate system are area, shape, distance, and direction. So why there are different projected coordinate systems? Because no projection can preserve all four of the spatial properties area, shape, distance, and direction. If some properties are maintained, errors in others may be exaggerated. Different PCS preserve different properties, so local projection systems are used to preserve properties and minimize the effect of distortion. Let's see what is prime meridian and center meridian. A prime meridian is the meridian in a geographic coordinate system at which longitude is defined to be 0, while the central meridian is the center line of longitude for projection systems used by projected coordinate systems as a reference point for an X origin. Let's see what is an equator. An equator is an imaginary line around the middle of a planet or other celestial body. It is halfway between the North Pole and the South Pole at 0 degrees latitude. An equator divides the planet into a northern hemisphere and a southern hemisphere. False easting and false northing, two important terms in map projection. False easting is a linear value applied to the origin of the x coordinates, while false northing is a linear value applied to the origin of the y coordinates. False easting and northing values are usually applied to ensure that all x and y values are positive. Scale factor. Scale factor is a unitless value applied to the center point or line. So, as we have covered some of the basic terminologies, let's explore in the software now. First, let's explore the coordinate system settings and set up projected coordinate system. Opening ArcMap, if we go to the data frame properties, we can see coordinate system. Inside that, there is favorites where frequently used projection systems are shown. Next, there is geographic coordinate systems based on regions like inside Asia. We use the Everest Bangladesh in our country. Next, in projected coordinate system, there are systems like UTM 9. Inside that, there is WGS 1984. In the northern hemisphere, Bangladesh falls in both UTM 45 and 46 zone. As distortion can happen, local projection system BTM is used too. Then we can see there is add to favorites where we can use any frequently used system. Beside that, there is option for clearing or adding a new geographic or projected coordinate system. If we want to define a projected coordinate system manually, we can click on it and select its name. Then select the projection name for BTM, which is transverse marketer. We can scroll and search for it. Next, we can set up the parameters manually for the projection system such as false easting and then the false northing. After that, the central meridian and the scale factor. Then we have to select geographic coordinate system, which is Everest Bangladesh. Then we have to click OK. Then we have to click OK for a few times. Thus, a projected coordinate system is set in the data frame. Now let's see how to set projection for undefined feature class. First, if we go to layer properties and check the source, we can see that there is no coordinate system defined. Then we go to arc toolbox and then projection and transformation tool, and inside that define projection tool. In input feature, entering the feature class, and then we have to select the coordinate system. As I am working with an area for Bangladesh, I am selecting BTM. For other case, we can define the projection system as previously shown. Now if we click OK and then go to layer properties and check source, we can see that the coordinate system is defined to BTM. We will work now with on-the-fly transformation. Let's take a new data frame and set its coordinate system, like for now as UTM-45N. Now if we place a feature class newly acquired area which we set to BTM projection previously, we can see a warning window pops up showing the coordinate system doesn't match. Clicking on the transformation will pop up another window. Here we can see convert from coordinate and target coordinate system. In the method section, we can select the method for transformation. If we have a method as I have worked before, but for new ones, click on new. Now we have to select the name and target accordingly. Next we have to select the method and set parameters accordingly. Click OK and then close now. The feature is adapted with data frame coordinate system. If we go to properties and check source, the coordinate system of the feature has not changed, but we can still work according to the data frame. This is how fly on the transformation works. Now, if we take a new data frame and put a projected feature and a not projected same feature class, we will see there is a difference between their positions. That is why it is important to use on-the-fly transformation or project tool to match data frame and features coordinate system. Now we will go to Arc Toolbox and select the projection and transformation tools in Data Management tool and open project tool. The unprojected feature will be inserted in input. Now let's set up the output and target coordinate system. If we bring out the output from the ARC catalog and put it in the data frame and change the color, we can see that the previously projected feature and currently projected feature are in the same position. Thank you everyone for watching till the end. Hope this tutorial will be helpful to you.